Hi, this is video 5 for lesson 4 from chapter 5, and I'm going to start off with example 4 from lesson 5.3 that I left out of the last video. So on page 196, example 4 talks about changing a percent to a fraction in simplest form. So again, couple different strategies on how to do these problems, and I am going to show the way the book shows for example 4, but I'm also going to talk about some other strategies for doing these problems. So look through example 4, 33⅓% as a fraction in simplest form to see how they did that. And let's pop down to 4a on page 196, which is 4.5%. So 4.5% is another way you could write that is 4.5%. And one strategy is just to move that decimal 2 places to the left to get 0.045. And the way you say that fraction, the decimal, the appropriate way is 45 thousandths. So I'm going to write down 45 over 1,000. And then I can reduce that by 5. So 45 divided by 5 is 9. And 1,000 divided by 5 is 200. And you can go ahead and check on your calculator. If you type in 9 divided by 200, then you should get that decimal 0.045, and if you change that to a percent, it's 4.5%. So that's a strategy that's not shown in your textbook. I'm going to do that same exact problem now with the strategy that the book presents, and that's what this looks like. So 4.5%, I'm going to write down 4.5%, and I'm going to write that as a complex fraction, and we know that percent means per 100. So 4.5% is written like that, 4.5 over 100. And so I'm going to get rid of the 100 by multiplying by the multiplicative inverse, or the reciprocal, which is 1/100th. And I'm going to multiply by 1/100th. In the numerator here, I'm going to change 4.5 to a improper fraction. So that's 9 over 2 times 1 over 100th. And guess what I get? 9 times 1 is 9, and 2 times 100 is 200. Don't you love it when there's more than one way to do problems? That's what math's all about. So don't get stuck always on just the way that's shown in the textbook or just the way that your teacher shows you, because there's more than one way to do it. I'm going to do one more example, and that's 12.5%. Okay, so 12.5% is actually one that you should have memorized. And so if you want to stop right now and figure that out, you can, and then hit play when you're ready. But 12.5% is actually 12.5. And if I move that back twice, I get 0.125, which is 1/8, a fraction decimal conversion that I have memorized. But again, showing the way that the book explains is another strategy. So I will write that as 12.5% per 100, and then multiply by the reciprocal, 1/100th, so that we can get 1 in the denominator. Multiply by 1 over 100. 12.5 as a improper fraction is 25 halves times 1/100th. We can cancel here and get 1 times 1 is 1, and 2 times 4 is 8. You get the same answer. So sorry about that I left that out on the last video for section 5.3. And now we're going to take a look at section 5.4, which talks about dimensional analysis. So 5.4 is talking about converting rates, and dimensional analysis is just a process of using units of measurements as factors when you can compute. So let's take a look here at example 1. Converting 100 miles per hour to miles per minute. Well, dimensional analysis allows you to set up those individual items and do some cross-canceling so that you can end up with the units that you want. So let's take a look at example 1 at the bottom on page 200, financial literacy. It says that the average teenager spends $1,742 per year on fashion-related items. That's 1,742 in 1 year. And it's asking us to convert that to weeks. Well, we know that there are 52 weeks in 1 year, okay? But in this case, I want my years to cancel out. So I'm going to put 1 year right here so that we can cancel those out. And then we're going to put down 52 weeks in the denominator of that fraction. So now we have 1742 times 1, which is 1742, divided by 52 weeks. And we can take 1742 divided by 52 and get $33.50 a week. Moving ahead to page 201, example 2. It is having us doing some conversions with a customary measurement system with feet and miles and things like that. So you can look through the example at the top of page 201 to see how they set up that one. I'm going to go down to 2A and help you figure out the extension problems there. So the TGV is a high-speed rail train in France, and at its top speed it runs an average of 320 kilometers per hour. So that's 320 kilometers per 1 hour. When I'm doing these dimensional analysis problems, I start with what I'm given here, 320 kilometers per hour. Then it wants me to go to meters per second. So I'm going to start with my time, and I'm going to figure that out to get from hours to seconds. And how I do that is working in smaller chunks to get from hours to seconds. So I know that there are 60 minutes in 1 hour. So I'm going to put 1 hour over 60 minutes. Now think about that for a second. Why did I put 1 hour over 60 minutes instead of 60 minutes over 1 hour? Does it matter? Have you thought about it? Well, it does matter because I want to cancel out the units, and I can cancel across here, but I can't cancel horizontally. So the next one I have to get from minutes to seconds. So I know that there are 60 seconds in 1 minute. Is my next fraction going to be 60 seconds over 1 minute or 1 minute over 60 seconds? Well, I'm going to put 1 minute in the numerator so that I can cancel out the minutes. And then I'm going to get 60 seconds in the denominator. Now you might be wondering, could I just take away one of these and do 1 hour is 3,600 seconds? Yes, you can do that. It's a preference of mine just to work in those smaller chunks of information, so that's the way I did it. But you could do 3,600 seconds in 1 minute. Finally, I have to get kilometers to meters, and I know that there are 1,000 meters in 1 kilometer. So here's kilometers. Am I going to have 1,000 meters is 1 kilometer, or 1 kilometer is 1,000 meters? Think about that for a second and write it down in your notebook. I'm going to do 1 kilometer is 1,000 meters so that I can cancel out the kilometers. So again, this is one strategy. Dimensional analysis is one strategy for solving a problem like this, and that's why I'm modeling it this way. So if this is brand new to you and it's kind of a stretch, not something that you've thought about before, please write it down, because it's one more tool or one more strategy that you can add to your math strategies. So what I have here to finish this problem is 320 times 1 times 1 times 1,000, which is 320,000. And then we have 60 times 60 times 1 times 1, which is 3,600. I can cross off a common 0 there and take 3,200 divided by 36 to get roughly 88.8 repeating, or in this case, the example says about how many meters per second is this, so we could say 89 meters per second. But you think about that, that's pretty fast. A meter is like this much, and 89 of those per second. That rail train is going pretty fast. For problem 2b, go ahead and write that out in your notebook and see if you can start it by yourself and hit pause on the video and then hit play again when you're ready. Again, this dimensional analysis, the first couple of times you do it, it's not super easy. But once you get the hang of it, it does become a nice little strategy to do these problems. I remember learning it in high school, and here you are as younger students learning how to do the same thing. So give yourself a break if you're a little frustrated or it's not something that's super natural for you, and try another problem. An adult cheetah can reach a speed of 70 miles per hour. So I'm going to start again with what I know, 70 miles per 1 hour. And it says, how fast is this in feet per second? So I'm trying to get to feet per second. Again, it doesn't matter if you start with miles or hours, but I'm going to try to get hours to seconds. And so in this example, I am going to use my little shortcut because I know that 1 hour is 3,600 seconds. And if you remember from the last problem, I got that by taking 60 minutes times 60 seconds to get 3,600. And the reason I put hours in the numerator here so that I could cancel them out. And now I have seconds, which is what I want for my answer. For feet, I've got to get from miles to feet. And if you don't have that conversion memorized, look on page 201, and there's some conversions from metric to customary and vice versa. But I don't see on there within customary measurements. So there are 5,280 feet in 1 mile, and I'm going to do 5,280 feet over 1 mile. And you might ask yourself right now, why did I put feet over mile instead of miles over feet? And if you said it's because you want to cancel that out, then that's the correct answer. What we have left here is 70 times 1 times 5,280 divided by 1 times 3,600 times 1. So you can use a calculator on these problems. I'm going to take 70 times 5,280, and I'm going to take that answer, 369,600, and divide that by 3,600 to get an answer of 102.6 repeating, or if you wanted to round that up, we could say 103 feet per second, which is also a pretty fast moving cheetah. When you think about a foot being about that, 103 feet per every second, it's a pretty fast animal. I wouldn't want to be in a race with that animal. All right, that was example 2, and let's take a look at the next page, which is page 202, and it's giving us a couple more examples of conversions. Using inches is about 2.5 centimeters. Make sure you're looking at these examples in your book and noticing when there's a video tutor available, because you can always watch those examples using those video tutors in your online book. Okay, and you also have example 4, another problem in dimensional analysis and converting between. So take a look at those videos. I'm going to do one last problem, which is at the bottom of page 202, number 4. It says, at a recent Winter Olympics, short track speed skater Apollo Ono won a gold medal by skating about 12 meters per second. Okay, so again, I'm going to write that down as 12 meters per 1 second. And then it says to round to the nearest hundredth how many miles per hour this is. Okay, so I'm trying to get to miles per hour. I'm going to start with my seconds and get 3,600 seconds in 1 hour. Again, I put seconds in the numerator so that I could cancel them. Now I've got to somehow get from meters to miles, and that's where you're going to need to go back to page 201 to find those metric to customary conversions. And what I see here is that 1 meter is about 1.094 yards. Now you might be saying, well, I don't want yards, I want miles. Well, in this case, I need to do a couple more conversions in my dimensional analysis to get to the unit that I want. So I'm going to start with what I'm given on page 201, which is that 1 meter equals 1.094 yards, okay? And the meters can cancel out. But I'm trying to get to miles, and so I've got to go one more conversion here to get yards to miles, and that is 1,760 yards in 1 mile. Okay, so again, if those aren't conversions that you know, you have some resources. You have what's on page 201, and you also have maybe some charts in your assignment notebook, or maybe you have another reference that you can look at for some of those customary and metric conversions. So this is how example 4 looks on the bottom of page 202. If we go ahead and simplify all that, 12 times 3,600 times 1.094 times 1, and then all of that divided by 1760. You can go ahead and figure that out while I get my calculator up and do it with you here. So $26.8527 repeating, and it said to round to the nearest hundredth, so we get 26.85, and that's miles per hour. Okay, so taking a look at the actual problem, we were given that short track speed skater was going about 12 meters per second. If that skater skated a mile, for 1 hour, they could skate about 26.85 miles an hour, which is pretty quick. So hopefully those couple of examples help you with section 5.4. And when we meet one-on-one, I'll also go through some more examples, because dimensional analysis can be tricky at first, but once you appreciate the process of working out problems that way, it becomes a really nice strategy to have in your toolbox.